NBA player makes 7 out of 10 free throws, do we have enough information to say they are 70% accurate? No, we don't. So here's how you actually run a Bayesian model to estimate an NBA player's free throw percentage. We're using R and Stan together. R is where we prep the data and call the model, and Stan is where the math happens. So let's say a player took 10 free throws and made 7 of them. In R, we start by creating a list with those values. N equals 10 and Y equals 7. This is what we're going to feed into the model. Then we call the Stan function. This function is part of the R-Stan package. We're going to tell it where to find the Stan file, what data to use, how many chains to run, how many iterations, and we're going to set up a random seed to make it reproducible. When we run all of this code, Stan is going to work using MCMC to sample from the posterior distribution of the player's actual free throw percentage, which we call theta. And after it runs, we can print a summary of the results. Things like the average value of theta and the 95% credible interval. This tells us what range the player's actual shooting ability most likely falls in. Then we extract samples of theta from the model output and we plot them. This histogram is the posterior distribution. It's showing us the full range of possible shooting percentages, weighted by how likely each one is, given the data and our prior belief. So that's everything in R. In the next video, I'll walk you through the actual Stan model so you can see how the prior, the data, and the math come together under the hood.